I'm going to report about the GIS data collection. Hello. I'm going to report about the GIS data collection. The data collection is split into two. Data capture, which is the direct data input, data transfer, input the data from the other system. There are two main types of data captures. There are primary data sources are those collected in a digital format for the specific use in the GIS project. The secondary source are the digital and analog datasets that were originally captured for another purpose and needs to be converted into a suitable digital format for the use again of the GIS project. Okay, in this part describes the data sources, techniques, and the workflows involved in GIS data collection. The process of data collection are also various referred to as data capture, data automation, data conversion, data transfer. Next is we go to the data collection workflow. Here are the first part: the planning, preparation, digitizing and transfer, editing and improvement, and evaluation. Okay, first one is planning. Planning includes the establishment, user requirements for garnering the resources and development of a project plan. Next one is the preparation. It involves the obtaining the data, redrafting for quality map, sources, editing scan map, images, removing noises, setting up the appropriate GIS hardware, and software system to accept data. Okay, followed by the digitizing and transfer are the stages where majority of the effort will be expanded. The next one is editing and improvement. It covers many techniques designed to validate data as well as to correct errors and improve quality. The last one is the evaluation. It's the process of identifying the project, whether it is success and failure. Okay, let's go to the primary data capture. Primary data under this is the raster data capture, which uses remote sensing. We know that remote sensing is a technique used to derive the information about the physical, chemical, and biological properties of the object without direct physical contact. So the information is derived from the measurement of the amount of electromagnetic radiation that is reflected with and emitted or scattered from object. So we know that resolution is the key physical characteristic of remote sensing system. Under this is the spatial resolution. It refers to the size of the object that can be resolved, and the most usual measurement is pixel size. Spectral resolution. It refers to the part of the electromagnetic spectrum that are measured. Next one is the temporal resolution, or repeat cycle, describes the frequency with which images are collected for the same area. Okay, next slide is about the primary data capture. Here are the two main branches, the surveying and the GPS. Okay, we know that surveying is based on the principle that the location of any point can be determined by measuring the angles and distance from other known as points. It traditionally equipped like a transit and satellite have been replaced by a total station that can be measured both angles and distance to an accuracy of 1 mm. Okay, the next is LiDAR. Relatively new technology that employs a scanning laser finder to produce accurate topographic surveys, typically carried in a low altitude aircraft that also has an inertial navigational system and differential GPS to provide the location. Next one is the secondary geographic data capture. Okay, the data collected for the purpose can be converted for the use of GIS. Here are the three main reasons to scan hard copy media. Media are under the raster data capture using the scanners. Other documents are scanned to reduce the wear and tear, improve access, provide integrated data storage, and to index them geographically. Film and paper maps, aerial photographs, and images are scanned and georeferenced so that they provide geographic context for the other maps. Maps, aerial photographs, and images are scanned prior to the vectorization. Okay, next one is the digitizing. So under this is the manual table. So the secondary vector data capture involves in digitizing vector objects from maps and other geographic data sources. Vectorization is the process of the converting raster data into vector data. Okay, it is the science and technology of making measurement from the pictures, aerial photographs, and images. So measurement are captured from the over. Okay, the next one is the photogrammetry. Again, it is the science and technology of making measurement from pictorial photographs and images. Measurement are captured from the overlapping pairs of the photographs using stereo platters or to images corrected for the variation in the terrain using DEM. Photogrammetry is a very cost-effective data capture technique that is sometimes the only practical method of obtaining detailed topographic data. Oh, the next one is COGO, or coordinate geometry. It is the contract of the term coordinate geometry methodology for capturing and representing geographic data. It uses a survey cell bearing and distance to define each part of the object. COGO data are very precise measurement and often regardless as the only legally accepted definition of land parcels. And that is the end of my report. Thank you.